Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniel here, and today I'll be talking about capital assets pricing models. This is my second lesson in the series of IFM, the preparation for investment and financial mathematics exam. This lesson will cover the Sharpe ratio, beta of investments, capital assets pricing model, uh, the capital market lie and the security market lie, and some practice. Alright, so now let's begin with the Sharpe ratio. What is the Sharpe ratio? The Sharpe ratio measures the return on an asset relative to its volatility. Here I use phi as a notation for the Sharpe ratio, and the Sharpe ratio of this asset is risk premium over volatility. And the risk premium here is the difference between the expected return and the risk-free rate. And volatility here is the standardization of the return. So I can use either VOL of RP or sigma of RP as a notation for volatility of this investment. Here RP is the rate of return on the portfolio. RF is the risk-free rate. And VOL of RP is the volatility or the standardization of the return. The risk premium here is the incremental return since we borrow at the rates RF for this investment. In general, usually people don't have cash in hand in order to invest into an investment. People usually borrow money to invest, and here we assume the risk-free rate is RF. The second thing that is important is the beta of investment. Beta is a measure of risk in capital asset pricing model. And the beta of an investment I with respect to the portfolios is notated by beta IP, and it is the ratio between covariance between the rate return of the portfolio and the rate return of the investment I over the variance of the portfolio P. And remember, covariance between RP and RI is correlation coefficient between RP and RI times with volatility of RI times volatility of RP. Here the volatility of RP cancel with the variance of RP, so the denominator is volatility of RP. Remember, variance is the square of the volatility. So this is how we compute the beta of investment I with respect to the portfolios. And the investment I increases the Sharpe ratio if the risk premium is RI subtract RF of the investment I is greater than the beta of investment I with respect to the portfolio times with the risk premium of the portfolio. Here, the left-hand side of this inequality represents the risk premium of the investment I. And the right-hand side in the bracket is the risk premium of the portfolio. And derive this formula by adding RF into two sides of this inequality. We have the expected return of investment I should be greater than RF plus beta IP times E RP subtract RF. And the whole thing on the right hand side is called the required return. Usually if the expected return RI is equal to this required return, we have an efficient portfolio. Now we are going to make connection between beta and Sharpe ratio. The Sharpe ratio is increased if and only if. Here I use an inequality. The left-hand side is expected return of investment I subtract the risk-free rate RF over the correlation between RP/RI times the volatility of RI. This is greater than expected return of portfolio subtract the risk-free rate RF over volatility of RP. we notice that the right hand side of this inequality is the Sharpe ratio of the portfolio, because the numerator is the risk premium of the portfolio and the denominator is the volatility of the portfolio. So we got phi. This is the Sharpe ratio of the portfolio. Now if we look closely in the left hand side of the inequality, we see there's something familiar, right? The numerator is the risk premium of investment I, and the denominator is the volatility of investment I. So if we make correlation between RP and RI disappear, we got the Sharpe ratio of investment I. So let's do it. I'm going to multiply both sides with correlation between RP and RI. This is in the purple color, right? I'm going to make it disappear in the left hand side. So by doing so, the left hand side becomes the Sharpe ratio of investment I, and the right hand side is a product between the correlation between RPRI and the Sharpe ratio of portfolio. And I can use different notation for correlation. I use rho IP as the correlation between RPRI. This is just a notation to make the notation, it's just for convenient purposes. It doesn't make any difference. Now I have my connection between phi I and phi. Phi I is the Sharpe ratio of investment I, and phi is the Sharpe ratio of the portfolio. And we see that phi I is rho IP times phi. Now the next thing I want to appear the beta of investment. So what I'm going to do next is, you see here we have on the right hand side we have correlation coefficient between RPRI and volatility of RP. Now suppose if you have volatility of RI on the numerator, then you will have the beta of investment. So let's do it. I multiply both sides with volatility of RI. So I got correlation between RPRI times volatility of RI over volatility RP on the right hand side, times with the risk premium of the portfolio. And if you look at this ratio, if you multiply both numerator and denominator with volatility of RP, the numerator becomes the covariance between RP and RI, and the denominator becomes variance of RP. And this ratio is nothing but the beta of investment I respect to the portfolio P. So we got the risk premium of investment I is greater than the beta of investment I respect to the portfolio P times with the risk premium of the portfolio. And now I move RF to the right hand side by adding RF to both sides. I got expected return of RI is greater than the required return. This is called the required return. And this is the thing that make up the security lie, the security market lie, which is introduced in the next few slides. Usually if the expected return of investment I is exactly this required return, we have an efficient portfolio. Now we go to the most important thing of this lesson, capital assets pricing model. The CAPM, which is the capital asset pricing model, is basically a tangential manner, which says that the return RI on any asset is equal to the risk-free return plus beta I times the risk premium. Here we got expected return RI is equal to RF plus beta I times expected return of RM minus RF. Here we use the market portfolio instead of the portfolio, so that's why we got RM. And when we use the market portfolio, we don't need P on the top of PI. Beta I. Beta I here is the beta of investment I with respect to the market portfolio. And this is the equation of the expected return RI. However, in the real life, expectation and reality are quite different. So the true value of the return RI is actually this quantity plus some error. And there are two type error here. The error come from the model and the error come from uh, the index I. So we got RI, the true value of the return RI is equal to RF plus beta I times risk premium of market portfolio plus alpha I and epsilon. This model is similar to linear regression. You see any model that is on the mathematics base, we actually use linear regression, and this model is similar to that. And here, if we differentiate both sides respect to RM, the return of the market portfolio, we got beta I. Because RF is a constant, so when you differentiate respect to RM, this is 0. And beta I is a coefficient of RM, so we got beta I. And alpha I and epsilon will disappear. So we got DRI over DRM is beta I. And this is the slope of this line. So we see that the beta of this investment is the slope of the line. Therefore, beta explains the change in the return of an investment per unit change in the return of market portfolio. Remember, for a line, the slope explains about how steady the line is. So in the real life, beta explains the change in the return, whether we got a big change or a small change of an investment per unit change in the return of the market portfolio. And in capital asset pricing model, there are two important lines. One is capital market line, and the other one is the security market line. So let's consider the first line, capital market line. The capital market line equation is RP is equal to RF plus RM subtract RF over sigma M times sigma P. Here RP is the return of the portfolio, P stands for the portfolio, RM is the return of the market portfolio, M stands for the market, RF is the risk-free return rate, and sigma M is the volatility of the market. Sigma P is the volatility of the portfolio. And here we notice RM subtract RF is the risk premium of the market portfolio, and sigma M is the volatility of the market portfolio. So we got the Sharpe ratio of market portfolio here. So we see that the return of the portfolio is equal to the risk-free rate plus the Sharpe ratio of the market time with the volatility of the portfolio. So this equation makes connection between RP and sigma P, and if we sketch this equation on the coordinate system, we can use the volatility as the x-axis and RP as the y-axis. That's why when you look at the graph here I use R or P, it doesn't matter. R and P are both for portfolio. So the y-axis is the expected return of the portfolio, and the x-axis is the volatility or the standard deviation of the portfolio. So the capital market line is basically a line that represents the relationship between its expected return between the expected return of the portfolio and its volatility. Here we have couple conclusion here. Portfolios that fall on the capital market line CML, in theory, optimize the risk-return relationship, thereby maximizing performance. So on the exam, if you have a question like which of the following are efficient portfolios, then you have to pick all the portfolios that on the line of the capital market line. And the slope of this line, the slope of the capital market line is the Sharpe ratio of the market. because if you differentiate the capital market lie equation respect to the volatility of the portfolio, we got phi m, which is the Sharpe ratio of the market. As a generalization, we buy assets if the Sharpe ratio of it is above the capital market lie, and sell it if the Sharpe ratio is below. Because the Sharpe ratio is the Sharpe ratio of the market is the slope of the capital market line. So if the Sharpe ratio of the assets is greater than the Sharpe ratio of the market, we buy it. Otherwise, we sell it. The slope of the line represents how steady the line is. So that was the capital market line. Now we consider the second line, the security market line (SML). Different from the capital market line, the security market line consider expected return of the individual investment towards the market portfolio. Remember the capital market line, we consider the portfolio towards the market portfolio. Here we consider individual investment toward the market portfolio. And in the capital market line, phi m, the Sharpe ratio of the market, was the slope of the capital market line. Now for the security market line, we use beta I as the slope of the line. The equation of the security market line here is expected return of RI is equal to RF plus beta I times expected return of the market subtract RF. Here beta I is the beta investment I respect to the market. RI is the return of time I, or the return of the individual I. The risk-free rate here is RF, and RM is the market return. Here expected RM subtract RF is the risk premium of the market. And on this line, if we consider beta I is X and expected return RI is Y, we also can sketch the line on the coordinate system. Here I use X as beta and Y as the expected return. There are two ways to explain the slope here. If you look at the equation, if you differentiate both sides respect to beta I, we got the slope of this equation is expected RM subtract RF, which is the risk premium of the market. The second way to look at the slope here is when you look at the line, the security line on the coordinate system, we consider this right triangle in the red color. You see that? So the slope here is rise over run, right? The rise here is expected return of the market subtract the risk free. Subtract is for the market. One thing you have to notice here, for the market portfolio, beta is 1 because it's the beta of the market toward the market, so it should be 1. And let's say this is expected return of the market. So let's consider this rise over run. The rise here is expected RM subtract RF. That is the expected return of the market subtract the risk-free rate. And the run here is go from 0 to beta M, and beta M is 1. So the denominator is 1 subtract 0, which is 1. So the slope of this line is expected value of the market return subtract the risk-free rate. See that? So we see that the difference between capital market line and the security market line is, first, the capital market line make connection between the return of the portfolio towards the market portfolio. The security market line make connection between the expected return of the portfolio individual I with the market portfolio. The second thing, the second difference is the capital market line make use of the Sharpe ratio. The Sharpe ratio of the market is the slope of the capital market line. For the security market line, we see that they make use of the beta of investment, and the slope is the risk premium of the market. Yeah, those were the two main differences between security market line and capital market line. And some more characteristics of the security market lie. Security market lie here, this is the equation of the security market lie. And we got zero beta security or zero beta portfolio has an expected return on the portfolio which is equal to the risk-free rate. So we see here, if we consider the diagram here, this is the security market line, and the security market line crosses the y-axis at the risk-free rate, right? That means when beta is 0, we got expected return should be the risk-free rate. The expected return of the investment should be the risk-free rate. That's why that portfolio is said to be the zero beta portfolio. So we see that zero beta security or zero beta portfolio has an expected return on the portfolio which is equal to the risk-free rate. You see that when beta is 0, expected return is RF. The slope of the security market line is determined by the market risk premium, and it is expected return of the market portfolio subtract the risk-free rate. This is explained from the previous slide, right? Higher the market risk premium, steeper the slope, and vice versa. Remember, like the slope show how steady, how steeper the line is, right? So if we have high risk premium of the market, we got higher slope, like the slope is greater, and vice versa. All the assets which are correctly priced are represented on the security market line. So there are two conclusions here. On the capital market line, the efficient portfolio lies on the capital market line. And for the security market line, we got all the assets which are correctly priced are on the security market line. So the orange line here is the security market line, right? So any portfolio, any assets that ride on this line is said to be correctly priced. And if we got any assets that above it, we got undervalued stocks or undervalued assets. And otherwise, if the asset is below the line, we got overvalued stocks or overvalued assets. And between the capital market line, security market line, the capital market line is the line relating expected return of efficient portfolio to its volatility. Remember, capital market line make connection between expected return of portfolio toward its volatility, and any portfolio that lies on the capital line is said to be efficient. And this is the equation of it. The slope of the capital market line is the Sharpe ratio of the market. The security market line is the line relating the expected return of investment of beta. So here on the security line, we got the beta of investment and the expected return of the investment. And the slope of it is the risk premium of the market. And for the security line, remember, any assets, any stocks that lie right on the security line are said to be correctly priced. If it's above, it's underpriced. If it's below, is over value. Beta investment as function of beta is assets. Remember, beta of P is equal to summation xi beta I. So that was it. That was everything we need for this lesson. Now we are going to try some practice. And remember, the following exercises are just core examples. In order to have the best practice, please find and work on more exercises that relates to this topic. Alright, so let's consider the first problem. A portfolio consists of two stocks A and B. You are given beta of stock A with portfolio is 0.8. The annual effective risk-free interest rate is 0.05. Determine the correlation of stock A with the portfolio. Here we got a portfolio with two different stocks, and we invest 50% into stock A, 50% in stock B, because the proportion here is 0.5. You see that? So we invested 50% in stock A, 50% in stock B. The expected return of stock A is 0.15, of stock B is 0.18. the volatility of stock A is 0.2 and that of stock B is 0.25. So now solution. Our target is to determine the correlation between stock A and the portfolio. So it's a correlation between A and P. And here I use rho AP as a notation. And remember, correlation is covariance between A and P over sigma A, sigma P. Now, in order to determine the correlation coefficient, we have to find the covariance in sigma A and sigma P. Here, sigma A is given at 0.2. We got sigma A. We have to find sigma P and covariance between A and P. So let's write down sigma squared P. This is variance. Variance of P is variance of 0.5A plus 0.5B. And using the formula of variance, we got 0.5 squared sigma A squared plus 0.5 squared sigma B squared plus 2 times 0.5 times 0.5 rho AB sigma A sigma B. Remember, 0.5 rho AB here is covariance between A and B, right? 0.5 rho AB sigma A sigma B here is 0.5 covariance of AB, right? And just substitute the number in. We got, let's say, 0.0025625 plus 0.025 rho AB. So this is one equation. And rho AB is not given, so we leave it there. Now, covariance between A and B is covariance between A and 0.5A plus 0.5B. So it's become 0.5 variance of A. That is 0.5 times 0.2 squared, because sigma A is 0.2. Plus 0.5 rho AB sigma A sigma B, because it's 0.5 covariance between A and B. And covariance between A and B is rho AB times sigma A times sigma B. And just plug the number in. We got 0.02 plus 0.025 rho AB. You can stop my video if you cannot catch up. You can stop my video anywhere and try to derive these formula using on your own. These are basic formula of covariance and correlation coefficient. Now we got beta A. Since rho AB is not given, we have to find it, right? And we make use of the last piece of information, which is beta of stock A is 0.8. Here 0.8 is equal to beta of stock A and is equal to covariance between AP over sigma squared P. This is right at the formula of beta investment, right? Beta investment is covariance over variance. And covariance AP here is 0.02 plus 0.025 rho AB from the second equation. And the denominator sigma squared P is 0.0025625 plus 0.025 rho AB from the first equation. And solve this equation for rho AB. This is 0.8 is equal to this ratio. This is an equation of only one variable with degrees 1. So this is an easy equation, right? Just use some college algebra basics skill. We got rho AB is 0.1. So now we got rho AB. We got the correlation between A and B. That means we can find sigma squared P and also covariance of AP. Now we go back to this target formula. So rho AP here is equal to first covariance of AP is 0.02 plus 0.025 times rho AB, and rho AB is 0.1, so we put them into the numerator. We got 0.02 plus 0.025 times 0.1, and the denominator we take the whole thing of the covariance of the variance of the variance of P, take the square root time with sigma A. Sigma A is 0.2. Sigma P is square root of sigma squared P. Sigma squared P here is 0.0025625 plus 0.025 times with 0.1, because 0.1 is rho AB. See that? And it's a result in 0.670820. So this is the correlation of stock A with the portfolio. So this is the first problem. This problem is considered to be challenging, but if you keep practicing on it, you will get used to it. Second problem. The market risk premium is 7%. Stock A has a beta of 2.0 and an expected rate of return of 18%. Stock B has a beta of 0.5. Where is the expected rate of return of stock B? This problem makes use of beta of investment rate. So let's write out beta of A and beta of B. Solution. For stock A, we got expected return of stock A is equal to RF plus beta A times risk premium. This is from the equation between expected return and beta, right? The risk premium here is the risk premium of the market. And we got the risk premium of the market is 0.007. The risk-free rate is not given, but the expected return of stock A is 0.18. The beta A is 2, so we got 0.18 is equal to RF plus 2 times 0.07. And from here we got RF is 0.04. For stock B, expected return of stock B is equal to risk-free rate RF plus beta B times risk premium of the market. Here, the risk-free rate we have found from the last equation is 0.04. So put it here. Beta B is 0.5, and the risk premium here is 0.007, which is given as 7% right here. So we got stock B expected return should be 0.075, which is 7.5%. So that is problem number 2. Problem number 3, which of the following in the capital market line diagram is efficient? Remember from the capital market line, any portfolio, any asset that is right on the capital market line is said to be efficient. And here we have two assets, right? The risk-free assets RF and the market portfolio. So both of them are efficient. So we got both risk-free assets and market portfolio are efficient as they both lies on the capital market line. Problem number 4. You are given the following information with regard to the capital asset pricing model. The risk-free asset has a return of 3%. The return of the market portfolio M has an expected value of 8% and a variance of 14%. The beta of an correctly priced asset Q is beta Q, which is negative 0.4. Find the expected return of Q. So here, first thing first, we have to summarize the question. The summary here first, let's read the sentence one by one. The first one, the risk-free asset has a rate of return 3%. That means RF is 0.03. The second statement, the return of the market portfolio M has an expected value of 8%. So ERM, expected of return of the market portfolio is 0.08. And variance of 14%. So sigma square of M is 0.14. Now beta of an correctly priced asset Q. Correctly priced, that means this asset is on the security line, right? So we can make use of the security line equation. Beta Q is negative 0.4, and the question is, what is the expected return of Q? So here, let's look at the market portfolio M first. Of course, the market portfolio is also on the security line, right? So we are going to use the security line equation for both market portfolio and portfolio Q. For the market portfolio, we got expected return of the market portfolio is equal to RF plus beta M times risk premium of the market. Remember that beta M is equal to 1 because it's measure the risk of the market toward the market, so it should be 1, right? The risk-free premium of the market here is not given. That is what we have to find. RF is 0.08, right? So we got 0.08, RF is 0.03, and expected return of market is 0.08. So we got 0.08 is equal to 0.03 plus the risk premium market. So from here we got the risk premium market is 0.05. And now we consider the portfolio Q, which is also on the security line because it is correctly priced, right? Assess Q, expected return of Q is equal to RF plus beta Q times risk premium of the market. Here the risk-free rate is 0.03, beta Q is given as negative 0.4, and the risk premium is 0.05, so we got the final answer is 0.01. So the expected return of the portfolio Q is 1%. So that was it. After you finish this lesson, here's a couple of things that you need to remember. The target of this lesson is to understand and explain the basics capital asset pricing model. You should be able to calculate the Sharpe ratio and beta of investment. You have to be able to identify efficient portfolio using capital market lie. Differentiate between capital market lie and security market lie. So that was it. Thanks so much for watching my video. I hope you guys enjoyed my video and see you on the next video. Bye bye.